So now finally we can start with binomial theorem, and we'll start with the binomial theorem for positive integral index n. Now binomial theorem states that if I have an expression which is a plus b to the power n, where this n is a positive integral index, then we can write it as summation r varies from 0 to n, nCr a to the power n minus r into b to the power r. So if I'm going to expand it, I can also write it as, so this is a plus b to the power n. So first one will be nc0, then a to the power n, b to the power 0, nc1, a to the power n minus 1, b to the power 1, nc2, a to the power n minus 2, b to the power 2, and then generally nCr, a to the power n minus r, b to the power r, and then finally it will be nCn, a to the power 0, and b to the power n. So this is the statement of binomial theorem. So if I have to expand any binomial expression to the power n, then I can write a plus b to the power n as nc0, a to the power n, b to the power 0, nc1, a to the power n minus 1, b to the power 1, nc2, a to the power n minus 2 b square, nCr, a to the power n minus r, b to the power r, plus nCn, a to the power 0 and b to the power n. If we look closely, then for each successive term, the binomial coefficient is it is increasing by 1. So it is nc0, then it is nc1, then nc2, nCr and nCn. The power of b is also increasing from 0 to 1, 1 to 2, r and then n, and then the power of 8 is decreasing by 1 unit every time. So it is a to the power n, a to the power n minus 1, a to the power n minus 2, and finally it is a to the power 0. So either I can express it in summation form, which is r varies from 0 to n, nCr, a to the power n minus r into b to the power r, or I can write it in expanded form. Now say for example, suppose I have x plus y to the power 5. So I'll simply write it as 5c0. Now this is x to the power 5, y to the power 0. Now the next one will be 5c1. So I'll write 5c1. Now power of x will reduce by 1 and power of y will increase by 1. So it is x to the power 4, y to the power 1, 5c2, x cube, y square, 5c3, x square, y cube, 5c4, x into y to the power 4, and then finally 5c5, x to the power 0 and y to the power 5. So what is 5c0? 5c0 is simply 1 and y to the power 0 is 1. So I'll simply write it as x to the power 5. Now 5c1 is 5. So 5 x to the power 4 into y. Now 5c2 is 10. So it is 10 x cube y square. Now 5c3. Now 5c2 is same as 5c3. nCr is same as nCn minus r. So again it will be 10. So it will be 10 x square y cube. 5c4 is same as 5c1. So which is again 5. And then 5c5 is 5c0. So it will be simply y to the power 5. So the expansion of x plus y to the power 5 is x to the power 5 plus 5 x to the power 4 into y plus 10 x cube y square 10 x square y cube plus 5 x to the power x into y to the power 4 plus y to the power 5. Now there are certain observations. Now the first observation is number of terms. Now since this series, the value of r starts from 0 and it goes all the way up to n, so the total number of terms in the expansion will be simply n plus 1. So there will be n plus 1 terms in the expansion. Now the second observation is, if I look at these binomial coefficient, nc0 is same as nCn. So nCr is same as nCn minus r. In the same way, nc1 is same as nCn minus 1. nc2 will be same as nCn minus 2. And from Pascal's triangle also, if you will recall, you'll notice that these terms or these coefficients are symmetric. So binomial coefficients of terms equidistant from the beginning and end are same. So that is nCr will be same as nCn minus r. So the coefficient of third term will be same as the coefficient of third term from the end. Now third observation is its general term. Now if I have to write general term, so we write general term as tr plus 1. I cannot write tr0. I cannot say zeroth term. So it has to be first term and then it goes all the way up to n plus 1th term. So that's the reason I'm writing it as tr plus 1. So its general term is nCr a to the power n minus r into b to the power r. So if I have any binomial expression which is a plus b to the power n, and if I have to write its general term, I'll simply say its general term will be tr plus 1, which is nCr a to the power n minus r b to the power r, where the value of r can vary from 0 to n. Suppose someone says find rth term from the end. So rth term from the end simply will be n minus r plus 2th term from the beginning. So if someone says find third term from the end, then it will be simply n minus 3 plus 2th term from the beginning. Now one of the expressions that we frequently use in binomial theorem is the expansion of 1 plus x to the power n. So if I write the expansion, I write nc0, 1 to the power n x to the power 0, nc1, 1 to the power n minus 1 x to the power 1, nc2, 1 to the power n minus 2 x to the power 2, ncr, 1 to the power n minus r x to the power r, and then ncn, 1 to the power 0 n x to the power n. So I can simply write it as 1 plus x to the power n as 1, or simply nc0, nc1 into x, nc2 into x square, ncr into x to the power r, and then plus ncn into x to the power n. Or I can simply express it as 1 plus x to the power n as summation r varies from 0 to n, and it is ncr into x to the power r. If I have to write general term, then its general term is simply given as ncr into x to the power r. Now suppose if I have any expression which says 1 plus x to the power n, and I have to find coefficient of x to the power r. So I know coefficient of x to the power r in this case simply will be ncr. So I'll directly write the result. So coefficient of x to the power r simply will be ncr. Now say for example, suppose I have the expansion of 1 plus x to the power 12, and suppose I have to write coefficient of x to the power 4. So in this expression, I know that coefficient of x to the power 4 simply will be 12c4. Or maybe for example, if I have, and suppose I have to find coefficient of x to the power 6. So I'll write it as coefficient of x square to the power 3. So here in place of x, I've taken x square. So here this coefficient will be simply 12c3. If the coefficient of x to the power 7 in the expansion of ax square plus 1 upon bx to the power 11 is same as the coefficient of x to the power minus 7 in ax minus 1 upon bx square to the power 11, then we need to find the value of a into b. Now for this series, or for this binomial expansion, which is ax square plus 1 upon bx to the power 11. So what I'll do is, I'll write its general term. So its general term is tr plus 1, and it is ncr. So it is 11cr a, which in this case is ax square to the power 11 minus r, and then b to the power r. So it will be 1 upon bx to the power r. 11CR, I'll take this a separately. So this is a to the power 11 minus r. I'll multiply this 2. So it will be x to the power 22 minus 2r. Again, I'll separate this b, 1 upon b to the power r, and then 1 upon x to the power r. So I'll take these 2x together. So I'll write 11CR a to the power 11 minus r, 1 upon b to the power r, and here will be x to the power 22 minus 3r. Now I need to find coefficient of x to the power 7. So that is this index 22 minus 3r, it should be equals to 7. So I need to find the value of r when 22 minus 3r is 7, because I need the coefficient of x to the power 7. So if I'll compare, I'll write 3r is 15. So the value of r is 5. So the term will be sixth term. So if I put the value of r as 5, I can write 11c5 a to the power 11 minus 5 is 6. 1 upon b to the power 5, and there will be x to the power 7. Now in the same way, I write the general term for the second expression, which is ax minus 1 upon bx square to the power 11. So its general term tr plus 1 will be 11cr ax to the power 11 minus r minus 1 upon bx square to the power r. So again it will be 11cr. I'll separate this a. 11 minus r. I'll also separate this b. Minus 1 upon b to the power r. So it will be x to the power 11 minus r. 1 upon x to the power 2r. I'll take this x together. So I can write 11cr a to the power 11 minus r minus 1 upon b to the power r, and it will be 11 minus 3r. Now in this case, I need to find coefficient of x to the power minus 7. So that is, I need to compare this value, which is 11 minus 3r with minus 7, and I'll get the value of r as 6. So in this case, the coefficient of x to the power minus 7 will appear with its 7th term. And if I put the value of r as 6, I'll get it as 11c6 a to the power 5 minus 1 upon b to the power 6, and this is x to the power minus 7. Now the question says these two coefficients, they're equal. So I'll just need to take the coefficients. So this is my coefficient from the left, and that's my coefficient from the right. So I'll equate them. So if I'll equate them, I can write 11c5 a to the power 6 upon b to the power 5, and this is 11c6 a to the power 5 upon b to the power 6. Now nCr is same as nCn minus r. So 11c5 is same as 11c6. Now a to the power 6 and a to the power 5, so it gets cancelled 5 times, and b to the power 5 and b to the power 6, it gets cancelled 5 times. So again I can write, so this is a into b, so the value of a into b will be simply 1. So this is how we use general terms in binomial theorem. So let us take up another question, which is find the coefficient of x to the power 53 in summation m varies from 0 to 100 cm x minus 3 to the power 100 minus m into 2 to the power m. So first I'll look at this term closely. So I'll write it again. I'll write it as summation. The value of m varies from 0 to 100 cm x minus 3 to the power 100 minus m, and will be 2 to the power m. Now this is nCr a to the power n minus r into b to the power r, where the value of r varies from 0 to n. So this is actually nothing but it is an expansion of a plus b. Now what's a in this case? A in this case is x minus 3. What is b? B is 2. And what is n? N is simply 100. So I can simplify this summation as x minus 1 to the power 100. So simply this question is find the coefficient of x to the power 53 in the expansion of x minus 1 to the power 100. So I'll write its general term. So its general term will be tr plus 1 is 100 cr x to the power 100 minus r minus 1 to the power r. Now I need coefficient of x to the power 53. So I'll compare the indices. So this is 100 minus r equals 53. So the value of r is 47. So if I'll put it there, So it will be my 48th term, and there will be 100C47 x to the power 53 and then minus 1 to the power 47. We'll just need the coefficients. So coefficient of x to the power 53 will be minus 100C47. So that is the answer to this question. So let us take up another question, which is, if in the expansion of 1 upon x square minus x cube to the power n, where n is any natural number, if the sum of the coefficients of x to the power 5 and x to the power 10 is 0, then we need to find the value of n. So again, in order to find the coefficient of x to the power 5 and x to the power 10, I'll just need to write general term for this expansion. So its general term will be, so tr plus 1 nCr 1 upon x squared to the power n minus r and minus x cubed to the power r. So I'll simplify it. So I'll write nCr and I'll write it as x to the power minus 2. If I'll multiply, I'll write minus 2n plus 2r minus 1 to the power r, and it will be x to the power 3r. So I can further write it as nCr minus 1 to the power r, and it will be x to the power 5r minus 2n. Now I need to find the coefficient of x to the power 5 and also the coefficient of x to the power 10. Now for coefficient of x to the power 5, I'll compare the index with 5. So I'll get 5, and suppose I'll say it is r1. So 5r1 minus 2n should be 5. So in this case, the value of r1 which I'll get is 2n plus 5 by 5. Now for the second one, I'll need to find coefficient of x to the power 10. So I'll compare this index with 10. So it is suppose r2. So this is 5r2 minus 2n is 10. So I'll write r2 as 2n plus 10 by 5, or I can write it as 2n by 5 plus 1, and it will be 2n by 5 plus 2. Now these are two consecutive terms. So it is 2n by 5 plus 1 and it is 2n by 5 plus 2. So now it says their coefficients, the sum of the coefficients is 0. So if I write the sum of coefficients, I'll simply write nCr1 minus 1 to the power r1 plus nCr2 minus 1 to the power r2, and it will be simply 0. Now out of this r1 and r2, one of it will be an odd number and the other one will be an even number, because they are two consecutive numbers. So that is, either way I'll get a minus sign in between that, right? So I can simply write it as nCr1 minus nCr2 should be equals to 0. So from here the condition I'll get is nCr1 equals nCr2. Now if I look at this condition, nCr1 equals nCr2. So either if nCa equals nCb, so either a is equal to b, which is not possible in this case because these are two consecutive numbers, or r1 plus r2 is equal to n. Now what's r1? r1 is 2n plus 5 upon 5, and what is r2? r2 is 2n plus 10 upon 5, and this value is equal to n. So I'll get 4n plus 15 is equal to 5n. So from here I'll say the value of n is 15. So the question is, find the sum of rational terms in the expansion of under root 2 plus fifth root of 3 to the power 10. So in this expansion, I know there are 11 terms, and out of these 11 terms, some of the terms will have irrational terms and some of the terms they'll be rational or free from indices. So there'll be questions where they'll ask you to find either the sum of rational terms or the number of integral terms or rational terms in a given binomial expression. So now again in this case, what I'll do is I'll write its general term. So its general term will be tr plus 1 10cr under root 2 to the power 10 minus r and fifth root of 3 to the power r, where the value of r varies from 0 to 10. Now I'll simplify it. I'll write 10cr. Now this is 2 to the power 1 by 2. So there'll be 10 minus r by 2 and 3 to the power r by 5. I can also write it as 10cr 2 to the power 5 minus r by 2 and 3 to the power r by 5. Now I need all these rational or integral terms. These two factors, r by 2 and r by 5, they are integers. So that is either the value of r is 0, because when r is 0 it will be simply 5 and it will be simply 3 to the power 0, or when r is a multiple of 2 and 5, which is r is a multiple of 10. So from here I'll get two values, either the value of r is 0 or the value of r is 10. So out of these 11 terms, these two terms are rational and the remaining 9 terms, they are irrational. Now I need to find the sum. So for r equals to 0, it will be t1. So there will be 10c0, 2 to the power 5, 3 to the power 0. And for r equals 10, there will be 10c10, 2 to the power 0, and 3 to the power 2. So 10c0 is 1 and 2 to the power 5 is 32. And here will be 9. So 32 plus 9 is 41. So let us take up another question, which is find the number of irrational terms in the expansion of fifth root of 3 plus cube root of 7 to the power 36. Now here total number of terms, it is simply n plus 1. So there will be simply 37. Now again I write its general term. So its general term will be 36cr fifth root of 3 to the power 36 minus r and cube root of 7 to the power r, where the value of r varies from 0 to 36. So I will take altogether 37 values. So I'll simplify it a bit. So I'll write it as 36cr 3 to the power 1 by 5. So I can write it as 36 minus r upon 5, 7 to the power r by 3. Now again the value of r should lie between 1 and 36. Now I'll first look for number of rational or number of integral terms, because that will be easy. So this series will have integral or rational terms when 36 minus r is divisible by 5 and r is divisible by 3. So 36 minus r is divisible by 5 and r is divisible by 3. So for all those values of r, and it should be an and, because I need both the conditions to hold simultaneously. So for all the values for which r is divisible by 3 and 36 minus r is divisible by 5, so in all these cases I'll have an integral term or rational term. So what I'll do is I'll write the values of r, and corresponding to that I'll write 36 minus r, which is divisible by 5. So if I'll take r as 1, so I'll get this value as 35. If I'll put r as 6, I'll get this value as 30. If I'll put r as 11, I'll get 25. If I'll put r as 16, I'll get 20. If I'll put r as 21, I'll get this value as 15, 26, 10. And if I'll put r as 31, I'll get this value as 5. And then if I'll put r as 36, I'll get this value as 0. So for all these values of r, this 36 minus r is divisible by 5. Now I need to find the condition also that this r should be divisible by 3. So out of all these values of r, 1, it is not divisible by 3, 6 is divisible by 3, 11 is not, 16 is not, 21 is, 26, it is not divisible by 3, also 31, and 36. So out of all the values of r, only 3 values, 6, 21 and 36 are divisible by 3. So out of these 37 terms, total number of rational terms, it will be simply 3, and total number of irrational terms will be 37 minus 3, which will be 34. So let us take up another question, which is find the term which is independent of x in the expansion of, now this expression which is x plus 1 upon x to the power 2 by 3 minus x to the power 1 by 3 plus 1 minus x minus 1 upon x minus x to the power 1 by 2 to the power 10. So this expression, it does look complicated, but then if we look closely enough, then there's some symmetry in the problem. So what I'll do is, I'll write it as, so I can write x as, it's a cube root of x, and then plus 1, and here will be x to the power 2 by 3 minus x to the power 1 by 3 plus 1. And what I'll also do is, I'll write this x as square root of x, and here I'll take square root of x common, and here will be x to the power 1 by 2 minus 1 whole to the power 10. Now I'll use the formula for a cube plus b cube. So formula for a cube plus b cube is a plus b, and then a square minus ab and plus b square. So in the denominator I have x to the power 2 by 3, x to the power 1 by 3 plus 1, and here a square minus b square, so it will be a plus b and a minus b, and here will be x to the power 1 by 2, x to the power 1 by 2 minus 1 whole to the power 10. Now in this case, I can cancel this numerator and denominator. Here also, I can cancel x to the power 1 by 2 minus 1. So what I'm left with is x to the power 1 by 3 plus 1, and here if I'll divide it with x to the power 1 by 2, I'll write 1 plus 1 upon x to the power 1 by 2 whole to the power 10. Now here this 1 and 1 will also cancel. So I can simplify this expression as x to the power 1 by 3 minus 1 upon x to the power 1 by 2 to the power 10. Now it's a binomial expression. So now I can write general term for it. So its general term, which is tr plus 1, will be given by 10cr x to the power 1 by 3 to the power 10 minus r, and then it is minus 1 upon x to the power 1 by 2 to the power r. So I'll write it as 10cr x to the power 10 minus r by 3 minus 1 to the power r, and 1 upon x to the power r by 2. So now I'll take these terms of x together. So I'll write 10cr minus 1 to the power r, and here will be x to the power 10 minus r by 3 minus r by 2. Now I need the term which is independent of x. So if the term is independent of x, then the index of x should be 0. So from here the condition I'll get is 10 minus r by 3 minus r by 2 should be 0. 20 minus 2r minus 3r equals to 0. So from here I'll get 5r is equal to 20. The value of r is simply 4. So it will be a fifth term, and the coefficient of fifth term will be 10c4 into minus 1 to the power 4. So answer to this question is 10c4. So let us take up another question. Now in this question, it's not exactly binomial, but still we can use binomial theorem to get the result. Now these kind of problems, they're generally done with multinomial theorem, but since we have not studied it, so we'll not discuss multinomial theorem in this case. So we'll try and solve the problem using binomial. So what I'll do is, I'll consider this 1 plus x as one term, which is a, and I'll consider this x cube as b, and then I'll write its binomial expansion. So if I write the binomial expansion, I'll write 9c0 1 plus x to the power 9 x cubed to the power 0, 9c1 1 plus x to the power 8 x cubed to the power 1, 9c2 1 plus x to the power 7 x cube whole square, and this series will continue. Now in this series, I need the coefficient of x to the power 5. Now for all the terms, including 9c2 and terms after that, the power of x will be 6 or greater than 6. So in all these successive terms, there won't be any term containing x to the power 5. So I'll get x to the power 5 either from the first term or from the second term. So 9c0 is simply 1. So I can write it as 1 plus x to the power 9, and 9c1 is 9, and here it is 1 plus x to the power 8 into x cube plus all other terms, they contains power of x which are greater than 5. So I'll get the coefficient of x to the power 5 from this series. So from this series, I need to find coefficient of x to the power 5, and here it'll be 9, and then we already have x cube. So if I get a term whose power is 2, then x square and x cube, they'll get multiplied, and then again I'll get coefficient of x to the power 5. So the coefficient of x to the power 5 in this expansion is, so from 1 plus x to the power n, the coefficient of x to the power 5 is simply nCn-r, which is 9c5. So this we have discussed in previous video, and then here it will be 9, and then coefficient of x square from 1 plus x to the power 8, which again is 8c2. So answer to this question is 9c5 plus 9 into 8c2. Now let us take another question, which is find the coefficient of x to the power n in 1 plus x into 1 minus x to the power n. So I'll write it as 1 plus x, and then it is 1 minus x to the power n. Now this expansion 1 minus x to the power n, it will contain the power starting from x to the power 0, and it goes all the way up to x to the power n. So whatever expansion I'll get from 1 minus x to the power n, so all these terms, they'll get multiplied with 1 plus x. Now in this question, I need to find coefficient of x to the power n. Now when do I get coefficient of x to the power n? So from this series, when x to the power n gets multiplied with 1, I'll get the coefficient of x to the power n. And also, when this x gets multiplied with x to the power n minus 1, so x into x to the power n minus 1 again will be x to the power n. So there are two ways in which I can get coefficient of x to the power n from the given series. So all I need to do is, I need to find these two coefficients. So the first one will be 1 into coefficient of x to the power n in 1 minus x to the power n, and plus, now here again coefficient of x is 1, and then here I need to multiply x with coefficient of x to the power n minus 1. So it is coefficient of x to the power n minus 1 in 1 minus x to the power n. Now I'll write its general term. So for 1 minus x to the power n, its general term is nCn-r minus 1 to the power r into x to the power r. Now for coefficient of x to the power n, I'll need to put r as n. So in that case, the coefficient I'll get is nCn minus 1 to the power n. So I'll write 1 into, now for x to the power n, I'll put simply r as n. So it'll be nCn minus 1 to the power n, and then plus 1 into, now coefficient of x to the power n minus 1. So for x minus 1, I'll need to put r as n minus 1. So if I'll put n as n minus 1, r as n minus 1, I'll get nc n minus 1 minus 1 to the power n minus 1. And here nCn, it is 1. So it is minus 1 to the power n. And then nCn minus 1 is simply n. So that is minus 1 to the power n minus 1. Now if I'll take minus 1 to the power n common, I'll get 1 minus n. So the coefficient of x to the power n in this expansion is minus 1 to the power n into 1 minus n. Find the coefficient of t to the power 24 in the expansion 1 plus t to the power 12, 1 plus t to the power 24, and 1 plus t square to the power 12. So first what I'll do is, I'll multiply these two factors. So I'll get 1 plus t to the power 12 plus t to the power 24 plus t to the power 36, and here I'll get 1 plus t square to the power 12. Now I need coefficient of t to the power 24. Now every term in this expansion gets multiplied with this factor. So I need t to the power 24. So I'll get t to the power 24 when this 1 gets multiplied with t to the power 24. When t to the power 12 gets multiplied with t to the power 12. And when t to the power 24 gets multiplied with t to the power 0. So these are the three cases. And for 36, I cannot make it 24. So here, the coefficient of t to the power 24 will be, so here the coefficient is 1, and from the right hand side I need coefficient of t to the power 24 in 1 plus t square to the power 12 plus, now again here coefficient is 1, so 1 into coefficient of t to the power 12 in 1 plus t squared to the power 12. And finally, coefficient of t to the power 0. Here again, the coefficient of t to the power 24 is 1. So 1 into, and then t to the power 0 in 1 plus t square to the power 12. So this is 1 into coefficient of, I can write t to the power 24 as t square to the power 12 in 1 plus t square to the power 12, 1 into coefficient of t square to the power 6 in 1 plus t square to the power 12, and then 1 into coefficient of t to the power 0, t square to the power 0 in 1 plus t square to the power 12. Now we have already done that. The coefficient of x to the power r in 1 plus x to the power n is nCn-r. So here it will be, so the coefficient of t square to the power 12 in this expansion will be simply 12c12. Now for this one it will be 12c6. And for the last one it will be 1 into 12c0. Now 12c12 is 1. So here it is 12c6 and 12c0 is also 1. So answer is 12c6 plus 2. 1 plus x to the power n into 1 minus x to the power n, and this is 1 plus 3x minus 6x square. Then I'll need to find the value of m and n. Now again in this question, it's a product of two given binomial expansions, right? So what I'll do is, at best I'll need the coefficient of x square and x. So I'll write first few terms of both the expansion. So for the first one I'll write, so we have already done this in previous video, which is 1 plus mx m minus 1 by 2 into x square. And for this one it'll be 1 minus nx, and it'll be n minus 1 by 2 into x square. Now if I look at the coefficient of x to the power 0, so when this 1 gets multiplied by 1, so I'll get this result as 1. Now plus, now I need to find coefficient of x. Now when do I get this x? When this mx gets multiplied with 1, and when this nx gets multiplied with 1, I'll get the coefficient of x. So if I'll multiply it with 1, I'll get mx. And if I'll multiply minus nx with 1, I'll get minus nx. Now I'll try and find coefficient of x square. Now when do I get this x square? So I'll get x square when this x square gets multiplied with 1. When this x square, it gets multiplied with this 1. And when this x gets multiplied with the other x. So there'll be three terms. So if I'll multiply them, I'll get, so this one here will be m minus 1 by 2 x square. For this one it'll be n minus 1 by 2 into x square, and then mx minus nx will be minus m into an x square. So I'll ignore all of the terms because they're not given in the question, right? So I can simply write it as 1 plus n minus nx. Now here I'll take x square common, so I'll write m square minus n plus n square minus n, and I'll take 2 LCM minus 2 mn into x square. So I'll simply write it as 1 plus m minus n into x, and here will be m square plus n square minus 2 mn, so it will be m minus n whole square, and then minus, so I'll take these two terms together, so this is minus m plus n upon 2 into x square. So now I'll compare the given series with the series which we have done, right? So if I'll compare the coefficient of x, so coefficient of x here is 3. So the first equation I'll get is the value of m minus n, it should be 3. Now I'll compare the coefficient of x square. Now for x square I'll get m minus n whole square minus n plus n by 2, and this value is equal to minus 6. So what I'll also do is I'll put the value of m minus n here. So m minus n is 3, 3 square is 9. So this is 9 minus n plus n will be minus 12. So if I'll solve it, I'll get this as n plus n. So 12 plus 9 is 31. So now I've got two linear equations in m and n. So if I'll add them, I get twice m, and this is 24. So the value of m is 12. And if I'll put m as 12, I'll get the value of n as 9. So answer to this question is the value of m should be 12 and the value of n should be 9. Find the coefficient of x to the power 7 in 1 minus x square plus x cubed to the power 6. Now what I can do is I can actually factorize it. So if I factorize it, I can write it as 1 minus x, and here if I take x square common, I'll again get 1 minus x whole to the power 6. So I'll write it as 1 minus x into 1 minus x square whole to the power 6. So I can simply write it as 1 minus x to the power 6 into 1 minus x square to the power 6. Now from this, I'll need the coefficient of x to the power 7. So as of now, I won't expand it. So I'll write it as 1 minus x to the power 6. And I'll expand the second one. So here I'll write 6c0 minus 6c1 into x square plus 6c2 into x to the power 4 minus 6c3 into x to the power 6, and all of the powers, they'll be greater than 7 because here after 6 will be x to the power 8. So here I'm interested in these first 4 terms. So I'll write 1 minus x to the power 6. Now this is 1. Now 6c1 is 6. So it will be 6x square. Now 6c2, 6 into 5 by 2. So it will be 15. 15x to the power 4. And 6c3 will be 20 into x to the power 6. Now I need to find coefficient of x to the power 7. Now I'll get x to the power 7 when this x square gets multiplied with x to the power 5. There is no x to the power 7 term in this because the highest power is 6. Now when this x to the power 4 gets multiplied with x cube, and when this x to the power 6 gets multiplied with x. So there are 3 ways with which I can get the coefficient of x to the power 7. So I'll write it as, so the first one is, so this minus 6, it gets multiplied with coefficient of x to the power 5 in 1 minus x to the power 6. Now the next one is 15, so plus 15 into coefficient of x cube and finally it'll be minus 20, and then it'll be multiplied with coefficient of x. Coefficient of x in 1 minus x to the power 6. Now if I write the general term, so tr plus 1 will be 6cr minus 1 to the power r into x to the power r. So if I have to find coefficient of x to the power r, so it'll be simply 6cr into minus 1 to the power r. So it'll be minus 6, and then coefficient of x to the power 5 will be 6c5 minus 1 to the power 5 plus 15. Now coefficient of x cube will be 6c3 minus 1 to the power 3, and then finally it will be minus 20 into coefficient of x will be 6c1 into minus 1 to the power 1. So minus and minus will be plus, so it will be 6, and then 6c5 is simply 6. So it will be 15 into minus 1 will be minus 15, and then what is 6c3? 6c3 is 20, and then minus and minus again will be plus, so there will be 20 into 6, so this is 36, 300, and there will be 120. So this value will be 156 minus 300, so I think it should be minus 144. The coefficient of x to the power 7 in this expansion will be minus 144. So let us take up another question, and which is find the coefficient of x to the power 5 in the expansion of 1 plus x to the power 21, 1 plus x to the power 22, and 1 plus x to the power 30. Now there are 2 ways of solving this question. Now one method can be, I know that in the expansion of 1 plus x to the power n, coefficient of x to the power r is given by simply nCn-r. So what I'll do is, I'll find the coefficient of x to the power 5 from this one. So from this one, coefficient of x to the power 5 simply will be 21c5. From the second one, it will be 22c5, 23c5, and finally it will be 30c5. Now I need to find a way with which I can simplify this series. So what I'll do is, I'll add 21c6 to the series. And because I've added it, I need to subtract it also. So there'll be 21C6. Now here I can say n is same and r differs by 1. So this is the property that nCr plus nCr minus 1, it is n plus 1 Cr. So I can write it as 22C6. Now again from this, n same, r differs by 1, 23C6, 24C6. So finally, if I'll continue, I'll get this as 30C6, and 30C6 plus 30C5 will be 31C6, and it'll be 21C6. So answer to this question simply will be 31C6 minus 21C6. So this is one way of solving the question using binomial coefficient properties. Now another way of solving the same question is, now what I know is it's a geometric progression. So 1 plus x to the power 21, 22 up to 30. So I can use the formula for sum of a geometric progression. So I'll find the sum of this geometric progression, and the sum of this geometric progression is a, now the first term is 1 plus x to the power 21 into r. What is r? R is 1 plus x to the power n, number of terms is 10, minus 1 upon r minus 1. So which is 1 plus x minus 1. So you get cancelled. So I can write the series as 1 plus x to the power 21 into 1 plus x to the power 10 minus 1 upon x. So if I multiply it also, I can write 1 plus x to the power 31 minus 1 plus x to the power 21 divided by x. Now from this series, I need to find coefficient of x to the power 5. Now whatever I'll get from the numerator, this x, it is going to reduce it by 1. So if I have to find coefficient of x from this entire expression, I'll need to find coefficient of x to the power 6 from the numerator. So I have to find coefficient of x to the power 6 in 1 plus x to the power 31 and minus 1 plus x to the power 21. So what is the coefficient of x to the power 6 in 1 plus x to the power 31? So there will be 31C6, and then minus, what is the coefficient from this? So it will be 21C6. So answer to this question will be 31C6 minus 21C6. So the question is, let n be the smallest positive integer such that the coefficient of x square in the expansion of 1 plus x square, 1 plus x cube, 1 plus x to the power 4, and it goes up to 49, and plus 1 plus mx to the power 50 is 3n plus 1, 51C3 for some positive integer n. Then I need to find the value of n. Now what I'll do is, first I'll simplify this series. Now it's a geometric progression. First term 1 plus x whole square, common ratio 1 plus x, and then number of terms 48. So if I'll simplify it, I'll write 1 plus x whole square, this is a, and then r, which is 1 plus x, number of terms 48, minus 1 upon r minus 1, 1 plus x minus 1, and then plus 1 plus mx to the power 50. So here I'll cancel this one. I'll multiply 1 plus x whole square. So I'll write 1 plus x to the power 50, and then minus 1 plus x whole square upon x plus 1 plus mx to the power 50. And from this series, or from this expansion, I need to find coefficient of x square. Now from this first expression, I have this x in the denominator. So whatever I'll get, if I'll get x to the power r, so I'll reduce it by 1. So I'll eventually get x to the power r minus 1. So if I have to find coefficient of x square from this expression, so from the numerator, I need to find coefficient of x cube in 1 plus x to the power 50 minus 1 plus x whole square, and from this one I'll just need to find coefficient of x square in 1 plus mx to the power 50. Now x cube, I cannot get x cube from this expression because the highest power here is 2. So the coefficient of x cube from this expression will simply be 50C3. So nCr. Now what about this one? So from this one, if I'll get the coefficient of x square, I'll get this coefficient as 50C2 into m square. Now it says this expression, it is equal to 3n plus 1, 51C3. So this is 3n plus 1 into 51C3. So I can simply write it as 50C3 plus 50C2 m square, and this is 3n plus 1 into 51C3. I'll convert these binomial coefficients into factorial. So this is factorial 50, factorial 3, factorial 47, factorial 50, factorial 2, factorial 48, and then this is 3n plus 1, and then it will be factorial 51, factorial 3, and then factorial 48. Now I'll write, so I'll take factorial 50 common, I'll also take factorial 2 common, and I'll also take factorial 47 common. So what I'm left with is 1 by 3, and here I'll get m square by 48, and here I'll write 3n plus 1. So this is 51 into factorial 50, and this is 3 into factorial 2, and this is 48 into factorial 47. So factorial 47, factorial 2, factorial 50 will cancel. So if I take LCM, I can write 16 plus m square upon 48 is equal to 3n plus 1 into 51 by 3 into 48. So 48 it will cancel, and there will be 17. So I can write it as 16 plus m square, and this is 51n plus 17. So I can write n as m square minus 1 upon 51. Now I need to put the value of m, so that m square minus 1 upon 51 results in a positive integral value n, and this m has to be the smallest value. So I can start with 1, 2, 3, 4. So eventually if you'll work it out, so I think the value of m you should get is 16. So I'll write m as 16. So there'll be 16 square minus 1 upon 51. So there'll be 16 plus 1, 17. 16 minus 1 is 15, which is 51, 3 and 5. So I'll get the smallest positive value of m at 16, and for that value of n, the value of n will result in 5. So answer to this question will be, the value of n should be 5. So let us take up another question, which is find the coefficient of x to the power 2016 in 1 plus x square x to the power 4 1001, 1 minus x to the power 1002, and 1 plus 7 x to the power 14. Now it's a geometric progression, so I'll write it sum, so which is a 1 minus r to the power n upon 1 minus r whole to the power 1001. This is 1 minus x to the power 1002, and this is 1 plus 7 into x to the power 14. So I'll write it as 1 minus x to the power 5 whole to the power 1001, 1 minus x to the power 1001, 1 minus x to the power 1002, and this is 1 plus 7 x to the power 14. Now it gets cancelled, so I'll write it as 1 minus x to the power 5 into 1001, and here if I multiply it, I'll get 1 minus x plus 7 x to the power 14, and then minus 7 into x to the power 15. Now if I write this expansion, I can write this expansion as summation r varies from 0 to 1001 nCn-r minus 1 to the power r x to the power 5 to the power r, and here I'll get 1 minus x plus 7 x to the power 14, 7 x to the power 15. Now I need to find coefficient of x to the power 2016. Now I'll get 2016 when 2016 gets multiplied with 1, when 2015 gets multiplied, when x to the power 2015 gets multiplied with x, when x to the power 2002 gets multiplied with 14, and when x to the power 2001 gets multiplied with x to the power 15. But what I see here is, I see all the powers of x, they'll be multiple of 5. So if they are not multiple of 5, there'll be no term containing that value or that power. So there'll be no term containing x to the power 2016, there'll be no x to the power 2002, there'll be no x to the power 2001. So the only coefficient or the only value of x possible in this case will be when x to the power 2015 gets multiplied with x. So answer to this question will be, so what is the coefficient of x to the power 2015? So for 2015, if I'll compare it with 5r, so the value of r is 403. So its coefficient will be 1001 c 403 minus 1 to the power 403, and it will get multiplied with minus 1. So its answer will be 1001 c 403. So let us take another problem, and the problem is, if p to the power 4 plus q cube equals 2, where p and q, they are both positive, then I need to find maximum value of the term independent of x in the expansion of p into x to the power 1 by 12 and plus q into x to the power minus 1 by 9 to the power 14. Now the first thing is, I need to find the term independent of x. So I write its general term, and its general term will be 14cr p x to the power 1 by 12 14 minus r and q x to the power minus 1 by 9 to the power r. So now I'll separate these p and q. So I'll write 14cr. Now this is p to the power 14 minus r, and this is q to the power r. Now here I can write x to the power 14 minus r by 12, and here I'll write x to the power minus r by 9. So now I'll take these terms of x together. So I'll write 14cr. Now this is p to the power 14 minus r, q to the power r, and here will be x to the power, now 14 minus r by 12 and minus r by 9. So now I'll take the LCM. So if I'll take the LCM, I can write it as, so this is 14cr p to the power 14 minus r, q to the power r, and this is x to the power 36. So this is 14 into 3 is 42 minus 3r and minus 4r. Now I need coefficient of the term independent of x. So if it is independent of x, so this index, this index should be 0. So here I'll get 42 minus 7r equals 0. So the value of r, it should be 6. So which term? So it is 7th term, and this term is given as 14c6 into p to the power 8 and q to the power 6. 14c6, and this is p to the power 4 into q cube whole square. So I need to find the maximum value of p to the power 4 and q cube. Now since p and q, they are both positive numbers, so I use arithmetic mean and geometric mean relationship. So the inequality says arithmetic mean between two numbers is always greater than or equal to its geometric mean. So what I can say is, so p to the power 4 plus q cube upon 2 will always be greater than or equal to p to the power 4 into q cube to the power 1 by 2. Now this value, p to the power 4 plus q cube is 2. So if I'll put 2 here, so 2 and 2 will cancel, so I'll get this 1. So 1 is greater than or equal to p to the power 4 into q cube to the power 1 by 2. So from here I can say p to the power 4 into q cube is always less than or equal to 1. So what is the maximum value of p to the power 4 and q cube? So its maximum value is simply 1. So if I'll put the maximum value here, so then the maximum value of this term, which is independent of x, is simply 14c6. So now the question is, find the sum of all the roots of the equation x to the power 2001 plus 1 by 2 minus x to the power 2001 equals 0. Now from theory of equation, we know that sum of all the roots of any equation or any polynomial equation which is S1, and we write it as summation over all I, alpha I, it is minus a1 upon a0, where a0 is the coefficient of highest power of x and a1 is coefficient of power of x, which is just one less than the highest power. Now suppose in this case it's a polynomial of degree n, so I can write a naught x to the power n plus a1 x to the power n minus 1. So what I'll do is, I'll write the expansion of this binomial series and I'll just write the last few terms. So I'll write x to the power 2001 and then here it'll be, so third last term will be 2001 c 1999 1 by 2 whole square and then minus x to the power 1999 plus 2001 c 2000. So it will be 1 by 2 to the power 1 and minus x to the power 2000 and then plus it will be 2001 c 2001 and it will be 1 by 2 to the power 0 and then minus x to the power 2001. So I can write it as, so this is x to the power 2001 now plus, now 2001 c 1999 I can also write it as 2001 c2, this is 1 by 4 and it will be minus and there will be x to the power 1999. Now 2001 c2000 it will be 2001 c1, it will be 1 by 2 and then it will be x to the power 2000 and then plus, so this is 1 and then minus, so there will be minus x to the power 2001. So x to the power 2001 will get cancelled. So it's a polynomial in degree 2000. Now what is a naught? A naught is 2001 c1 1 by 2 and what is a1? A1 is minus 2001 c2 into 1 by 4. So if I have to write the sum of all the roots, so it will be minus, and now what is a1? A1 is minus and minus will be plus. So 2001 c2 into 1 by 4 upon coefficient of x to the power 2000 which is 2001 c1 into 1 by 2. So if I'll write it, I'll write 2001 into 2000 divided by 2 into 1 by 4 and here will be 2001 into 1 by 2. So this 1 by 2 into will get cancelled. So 2001 will get cancelled. So I'll get this as 500. So sum of all the roots of this equation is 500.